Hello students, myself Somi Singh, Assistant Professor, KS Saket PG College, Ram Manohar Lohia University. I am teaching you the syllabus of BSc second year chemistry, paper 3rd, physical chemistry. In this paper, the unit 1 and 2 consist of thermodynamics. We will study these two units in 8 parts. I am writing here. Definition of thermodynamic terms. After that, first law of thermodynamics. Then in third part, we will study the second law of thermodynamics. In fourth part, we will study the concept of entropy. The concept of entropy. After that, we will study Gibbs and Helmholtz. Gibbs-Helmholtz functions. Then third law of thermodynamics. And finally, the chemical equilibrium. Chemical equilibrium and thermochemistry. So these 8 parts 1, 2, 3, 4, 5, 6, 7, 8 will cover whole of your syllabus of unit 1 and unit 2 of BSc second year paper 3 for chemistry, which is the physical chemistry. Now in this topic, definitions of thermodynamic terms. This is one of the most important topic, and if you are not understanding this topic, then I think it will be very difficult for you to understand rest of these. So first of all, we will start this topic, definition of thermodynamic terms, and in this topic we will study what is system and surrounding. ठीक है. After that, your type of systems. System and surrounding, then type of systems, and a topic is thermodynamic quantities. After the thermodynamic quantities, we will learn the extensive and intensive properties. extensive and intensive properties. After that, what are state functions and what are path functions. And their differentials. After reading the differentials, we will go through the concept of heat and work. And finally, in this part 1, we will also see what is a thermodynamic process. Thermodynamic quantity. What are thermodynamic quantities? The property of system. We have seen the system. What is system? What are surrounding? The property of system in which we are interested. We are interested in thermodynamic point of view. From thermodynamic point of view. Thermodynamic quantities. This topic. We are doing this. Thermodynamic quantities are quantities in which we are interested from thermodynamic point of view. For example, temperature. Now, speed and velocity, we are not interested in this thermodynamic topic. We are interested in quantity like temperature, pressure, volume, and your enthalpy, entropy, Gibbs energy. These all are your thermodynamic quantities. We also can say these thermodynamic quantity by different names. These are your state variables, thermodynamic function. I am writing different names. You don't have to confuse that what is this thing. So there is no difference. We can use them interchangeably. Thermodynamic function, thermodynamic function, thermodynamic variable, state variable, state function, thermodynamic quantities, which we are seeing here. So all the state functions particularly are your thermodynamic quantities. Now question for you: work and heat are thermodynamic quantities or not? Or not? After seeing these thermodynamic quantities, we are going to discuss what are your intensive and what are your extensive properties. So Intensive properties, I am writing this side. Extensive this side. The properties of a system or of a matter, or what's our the property which we are interested in seeing, system we are interested in seeing. The intensive properties are independent on amount of substance present in system. Independent on amount of substance present in system, your intensive properties. These are non-additive properties. And these independent intensive properties remains same on division of system. Example of your intensive properties are temperature, pressure, density, concentration, specific gravity, viscosity, and your surface tension, boiling point, melting point, etc. These are intensive properties. When we talks about extensive property, so independent on amount of substance present in system, these are dependent. These are dependent on amount present in substance. These are additive. And change on division. Change on division. Example of these properties are volume, heat capacity, length, free energy, enthalpy, mass. So these are your extensive and intensive properties. So students, we are discussing state function and path function. First of all, you need to understand what is actually a state is here in thermodynamics. I am drawing here a three-dimensional diagram. On x-axis I am taking volume, temperature and your pressure. Suppose at any point in these coordinate it is defined by p1, b1, t1. So this point is mathematically is state of a system. Means system is your at pressure p1, volume b1 and temperature t1. This stage will remain unchanged and same until we have not applied some external force in the form of heat or form of work. Now I am writing here it 1. If I am applying some sort of heat or I am doing some work on the system, then it will go to some other stage, say 2, P2, B2, T2. So change from this state to this state, from state 1 to state 2, is in thermodynamics called process. There may be different paths in going from this state to this state. Now, what is your state function? State function. It is a property. State function is a property of system whose value does not depend on path taken from one state to other. Means a state function is a property which is independent of the path. It depends on the initial stage and final stage. Example of state functions are your mass, energy, enthalpy, internal energy, Gibbs energy, pressure, temperature, volume, chemical composition and particle number. These all are your state functions. We also call them also knows by a name point function. So you can say either state function or point function, the meaning is same. Now come on the path function. Simple. You have to understand that state function does not depend on path. So path function will be depend on the property whose value depends on path taken. Example are work, heat, arc length, or a very simple, if you want to understand the students who are unable to understand what the point function or path function, I am simply saying that distance and displacement. Distance is your path function, displacement is your state function. Path function, state function. Because I am going from this point to this point, if I am going by this route and I am going by this route, in the both routes, both paths, the distance I will cover will be different, but the displacement between both points always be same.